Alright, hello everyone, and today join with my daughter Isabella, and we're going to be learning about multiplying and dividing algebraic rational expressions today. So this is a pretty great lesson. Hopefully it'll be short, sweet, and to the point. Okay, so here we go.
Music compilation.
Alright, so here's what we're going to be covering today. We're going to start with multiplication first. Okay, so to do this, first thing we're going to do is we're going to start by factoring everything. So here we go. So you have to factor everything. So that means you're going to be using the PS2. You're going to be using the slide. You're going to be using factor by grouping. You're going to have to do cubics and all that other fun stuff. Okay? So probably the most awful part of this whole process is this first step. Okay, then after that we're going to try to reduce, and we'll go over problems on how to do that. Okay? Then after that we're going to multiply, and then try to reduce one more time. Okay, so that's our step process. Okay. All right, so here's our first example problem. So we're going to start simple, and yes, we've done easy stuff like this before. Okay, so this is super simple, okay, but I wanted to start easy so you guys remembered how to do the basics, okay? So we have this problem over here, okay? So we have this right here. So we're going to start by reducing. We'll try to factor first. Okay, so step one, try to factor. But again, notice how, again, these are all monomials. This is one piece, this is one piece, this is one piece, and that's one piece. Okay, so I can't factor anything because everything's a monomial. So our next step is to try to reduce. Now remember, this is multiplication of fractions, so the regular numbers we can reduce up and down and diagonally. So like for instance, I can take the 3 and the 15. I can reduce this, okay, and cancel these out, and this is going to become a 1. That's a horrible 1, by the way, and a 5, so I'll fix that. Okay, don't mind the noise in the back, the baby's going berserk. Okay, so I gotta fix that again. That looks terrible. 1. Okay. Now, we also can go after the 2 and the 24, right? So 2 can cancel to 1, and 24 breaks down to 12. Okay, so we have this. Now, yes, as we discussed before, we can play the higher-lower game on the diagonals with the variables as well. But if you remember the last time we saw something like this, you guys really weren't comfortable doing that. So what we're going to do is, again, just like we did before, is we're just going to multiply across. Okay, so we've done our reducing right now, and let's go to the multiply step. So I'm going to bring all these other pieces we didn't touch down. So the x squared y, we had the r, the s, we have the r squared s, and x y to the fourth. Okay, times. So now we're going to multiply all this together. So remember our rules. Regular numbers get treated regularly, okay? Which means in English, since we are dealing with a multiplication function here, this 1 and this 12, we are going to multiply normally. So 1 times 12 is 12. Okay, now the x's, we're going to have x to the 12 squared, sorry, not 12. We're going to have y, we're going to have r squared, and we're going to have s all over. Now on the bottom, okay, we're going to, same thing, 1 times 5 is 5. Now when we do the bottom part, make sure you're lining up your variables, okay? So since this r, yeah, it leads us off, but again, we don't want to put under the x because then it's going to ruin our higher-lower game here. But the r, I can put under the r. The s can go under the s. The x can go under the x. And the y to the fourth can go here. All right? So we've multiplied. Now our last step says to reduce again if we can. In this case, we can because we're going to play the higher-lower game. We knew we had to do that because we discussed that earlier. Unless you played the higher-lower game earlier. Then again, at this point, you're just checking to make sure there was nothing you didn't leave behind. Okay, so let's play the higher-lower game. So again, for those of you who've never seen this before, again, here's our review. So regular numbers, again, get treated regularly. So treat the 12 over 5 like a normal fraction and try to reduce it. So can I reduce 12 over 5? The answer is no. So it stays as 12 over 5. Now for the variables. Now here's the higher-lower game. Now remember, to do the higher-lower game, we start by trying to find where the larger exponent of the variable is. Again, if it's in the top position, we call off higher. That was awful. I. And if it's in the lower position, we call off lower. All that does is it tells us where the variable is going to go. So between x squared, or x to the first, the larger exponent is in the higher position. So that tells me I'm going to put the x right here. Then what we do is we subtract the larger exponent from the smaller. So in this case, 2 minus 1 is going to be 1. So I can just leave it as x. Now we come to the y's. So between y to the first and y to the fourth, Bella, where's the larger exponent, in the higher or the lower position?
The lower.
The lower. So we're going to put the y down here, and then we subtract. Remember, there's a 1 here, so 4 minus 1 is going to be what?
3.
3. So there's our exponent. Now, between the r squared and the r, am I going higher or lower with the r's, Bella? Where's the larger?
Higher.
Higher. So we're going to put the r up here, and then 2 minus 1 is 1. And now for the last part, the s's, they're both the same. So since they're both the same, we're neither going higher or lower, so they cancel. So this right here is my final answer. Pretty simple. Again, we've done this all before. All right, so now it's going to get a little more fun now. Okay, that was an easy one the last time.
Teacher fun?
Okay, so here we go. So let's start off. First thing says to factor everything. Now as I look around here, the m plus 3 already factored. 5m is a monomial. I can't touch it. 20m squared, monomial. Can't factor it. But this guy, this is a trinomial, and that we might be able to factor, so we have to check that out. So again, because it has 3 pieces and no lead coefficient on the square, this is a PS2 problem. So let's go to our PS2. So PS2. Now, for those of you who don't remember PS2, the product or the P component is right here. So it's going to be positive 15. Okay. The S or the sum component is right here. So that's going to be positive 8. So now the hard part of this whole process. What two numbers multiply to 15, but add to give me positive 8? So again, we think about it, well, positive 3 times positive 5 gives me positive 8 when I add it, and positive 15 when I multiply. So those are my factors. So we're going to take this and do m plus 3 over 5m times 20m squared over, we have parenthesis, m plus 3 with m plus 5. All right, so we have now factored everything. Now, our next step says to reduce. Now, when we reduce this stuff, we've got to be careful. Now, again, kind of the rule is if there's stuff on the outside of a parenthesis, we're playing the higher-lower game with it. Okay, they're free and single. We can do whatever they want. But when we go stuff in the parenthesis, they have to be exactly the same in order to cancel it. Okay? So, for instance, let's start with the free and single pieces. That would be the 5m and the 20m squared. Okay? So I know that 5 and 20 I can reduce to 4 over here and 1 here. Now, for those of you saying, well, gee, let's try the higher-lower game with the variables, and we can do that at this stage. We don't have to put it all together right now. So, between m squared or m to the first, am I going higher or lower here with those m's, Bella? M squared is here, m to the first is here. Where's the larger exponent?
Higher.
Higher. So the m goes here, then we subtract. 2 minus 1 is 1, so that's that. Now we go to the pieces that are in the parenthesis. Now they have to be exactly the same to cancel it. So for instance, this m plus 3, I can cancel with this m plus 3. So we're going to X those out. Okay, and that just leaves a 1 up here because everything went away over here. And down here, we're left with the m plus 5. And again, I always keep the pieces with pluses and minuses in parentheses, and I'll explain why in a minute. Okay, so now at this point, let's multiply this together. So we've completed the reduce. Now multiply. So 1 times 4m is 4m. 1 times m plus 5 is m plus 5. Okay, so we've multiplied. Now our last step says to reduce again if we can. Now, here's what students want to do. And I'm going to warn you of this now. You cannot do this. Okay? Here's what students want to do. I'm looking at this right now. Oh, I see this m. I can cancel this, and I can cancel that. You can't do that at all. Okay? Let's see what this does. Yeah, it looks like it's going to erase the whole thing. Yeah, I don't want to do that. Okay, so let's see. Okay, so I'll just do this. I'll fix it this way. Okay? You can't do that at all, folks. Let's put those m's back. Reason being is, again, because of this. The pieces up here are free and single. They're monomials. This is a binomial down here held together with a plus sign. These are not free and single pieces. So you cannot put them, you cannot reduce them as reduce a monomial with a piece of a binomial. You can't do that. That's serial killer stuff. That's like going up to somebody and ripping an ear off because you thought it looked nice. You can't do that. Society frowns upon that, even during these hard and difficult times. Society frowns upon you taking ears off of people. Okay? So you cannot do that. So in this case, can we reduce anything here? The answer is no. This right here is our answer.
I was laying in there, I just got up a little while.
All right, so let's take a look at this next one. Okay, we have some garbage like this. Okay, no big deal. Now, the first thing we might notice is this second piece right here isn't a fraction. So first thing we do, we should make it 1. So put it over 1. Pretty simple. All right, so let's start our process. Okay, factor everything. So for this top piece here, I can take out a 3. So take out the 3, take it out as a greatest common factor, or GCF, leaving me x plus 5. Okay, underneath, now I look at this. Now again, I'm going to start with greatest common factor down here. I can take out a 4. Okay, so if I kick out a 4, I'm left with 2x squared plus 11x, 11x plus 12. Okay, times, now we're going to take a look at this. Again, I can't factor that with GCF to 2x plus 3 all over 1. Okay, now, here, let me fix that. That looks like a parenthesis. I don't like that. Hey, put it back. Okay, so let's do 11.
Ah.
Come on. Write the stupid thing. There we go. Okay. Okay, so now, from here, we need to still look at this. We might be able to factor this some more. So let's kind of pull this apart and see what happens.
Oh, yeah.
So let's take a look at 2x squared plus 11x plus 12. Okay, now this one, we're going to have to use the slide. You may know grouping method, whatever works for you, okay? But I'm going to use the slide here. So we're going to multiply front to back. Okay, so 2 times 12 is positive 24.
Yeah.
Okay, now we put in our slide. Okay.
Yeah.
So product is positive 24. The sum is positive 11. So our two numbers that do this are going to be positive 8 and positive 3. So we could factor this some more, and we're going to have to. So let's do this. So we're going to do x plus 8, x plus 3. But don't forget, when you do the slide, because we did the slide, you have to divide everything by the lead coefficient. So we got to divide this by 2, divide this by 2, and reduce. I'm going to have to shrink all this.
Well, are you going to try and go to work or what today?
Okay, so here we go. So let's reduce this. We're going to have
What, from home?
this reduces, so x plus 4. Now this one I can't reduce, so we're going to scooch this and make this 2x plus 3. And then don't forget about our our GCF we took out earlier, which is a 4.
I'm going to see it.
I see that.
Hello, humans.
So get Gwen Gwen in there. Everyone wants to see Gwen Gwen. There's the Gwen Gwen. Kind of. There she is.
Okay.
Hey Gwen Gwen.
All right.
All right.
Be safe.
So, so at this point, okay, so let's do, I gotta shrink this some more. I know, it's getting tiny that we can't see it. Okay, so now let's write our problem down. So we had 3 parentheses,
Okay?
x plus 5 over 4 x plus 4 with 2x plus 3 times, we have the 2x plus 3.
Doesn't mean that you correct us.
She's wanting some juice, honey. Why don't you go get her some juice?
Okay, sit down.
Here, you can scooch her off. Alright, so now at this point, let's start to cancel things. Let's start with the free and single pieces. Okay, here, Gwen. So you can see. There's Gwen Gwen. There's the Gwen Gwen. So now, start with the free and pieces, single piece on the outside. So we have the 3 and the 4. Now, if these are a normal fraction, I can't reduce this. So I can't do much with those. So 3 and 4. Okay, now let's go to the pieces in the parentheses. So x plus 5, I don't have any x plus 5s in the bottom, so I can't do that.
He understands that that's
But the 2x plus 3s, these I can cancel, this one with this one. Okay, so I'm left with 3.
English?
What do you need, Gwen? You want up? Well, you can't get up on the table, honey. Bella, she wants to be with Bella. X plus 5, all over the x plus 4. Okay, times, and again, this canceled to 1, so 1 over 1. So we've factored, we've reduced. Now let's multiply this. Okay, so 3x plus 5 times 1 is 3 times x plus 5. And 4 with x plus 4 is over,
What?
oops, 4 x plus 4. And now we've multiplied. Now my final step is to try to reduce if I can, but 3 and 4 again I can't reduce. X plus 5 over x plus 4, can't do anything. It's awfully tempting to go for these x's, but you can't. That's serial killer stuff if you do that. You can't do that. So,
That's evil.
there you go. There's your answer right then and there.
I don't think Jesus is not approved. Playing with your...
No, she's not. She can't get into it anyway. All right, moving on. All right, so let's take a look at this next one. All right. So again, step number 1 says to factor everything. So starting with this first one, the top here, I can take out a 4. Now, looking at this, I know many of my students are looking at this going, well, gee, I can cancel that, right? They're the same. Not quite. That's got a minus in it. The top's got a plus. So you cannot reduce that. Okay? We cannot reduce that. So let's take out a GCF. Top I can take out a 4, leaving me x plus 2.
Oh my god, this thing's killing me.
Over. Now on the bottom I can take out a 4, leaving x minus 2. Times. Now the top here we're going to PS2.
I got a bigger.
Okay. So the top we're going to PS2. So two numbers that multiply to 8 but subtract to give me 2 would be 4 and 2. So x plus 4, x minus 2. And then the bottom I can take out a GCF of 2, leaving me x plus 4. So I have this. Okay, so step 1, factor everything is done. Okay, step number 2. Okay, says to reduce. So I'm going to reduce up and down and diagonally. Now, I see the 4 in the top and the 2 in the bottom. I can go there. But I wouldn't really do that one because I would do this one. The 4 over 4 completely cancels. So why leave stuff behind when I can just completely cancel it and make it go away? That's much nicer, I would think. Okay, so now let's go to the pieces inside parenthesis. X plus 2. Well, I don't see an x plus 2 down here, so that stays. X plus 4. I have an x plus 4 right here, so these can cancel. So I make that go away. Then I have this x minus 2, and I got the x minus 2 down here, so these can cancel. So down here, I'm left with 1. Up here, I'm left with 1. Okay. Yeah. Okay, so reducing is done. So now let's multiply. So x plus 2 times 1 is x plus 2. Parenthesis up around plus or minus pieces, I always do. On the bottom, we're just going to have 1 times 2, which is just 2. And again, so multiplying is done. Now reduce. Again, it is awfully tempting to go for those 2's, but you can't. This is in a parenthesis with a plus sign. This is a monomial that's free in signal. You cannot cancel them. So as tempting as it is, this is your final answer.
That's really interesting.
Alright, so let's take a look at this next one now. What I'd like you to do is kind of start working ahead of me a little bit here and then catch up. Alright, hold on. So again, start working ahead of me. Again, I'm dealing with Gwen trying to mess with my computer. See, there it is. Okay, so let's, if you've started working, great. I'm going to start working behind you a little bit here. Okay, or if you want to complete the problem, you can pause the video, and then once you finish, then you can start hitting play, and I'll catch up to you. Alright, so let's get started. So first thing I'm going to do is I'm going to start to factor everything. So this top piece here, I can use PS2. So my product is -6, my sum is -1. So two numbers that multiply to 6 but subtract to 1 are 3 and 2. So I'm going to have x minus 3, x plus 2. Okay, over. Now x squared minus 9 is difference of squares. So we're going to have x plus 3, x minus 3, times. Over here, this is PS2. So two numbers that multiply to 12 but add to 7 are 4 and 3. So x plus 4, x plus 3. And then on the bottom, PS2 again, two numbers that multiply to 4 but add to 4, x plus 2 and x plus 2 again. Alright, so factoring is done. Now, reduce. So looking at my parentheses, there's no pieces on the outside. So, can't do that. So let's look at inside. So start x minus 3. I got an x minus 3 right there. Gone. X plus 2. I got one right here. Now I can't do both of these. Only one. So I can do this. Okay, and x plus 4. I don't have any x plus 4 on the bottom. That stays. And the x plus 3. I got one right here, so these cancel.
Gone.
So reducing, done. Next step says to multiply. So all this over here, this is 1, and this is now 1. So we're going to do 1 times the x plus 4, which is x plus 4, over 1 with x plus 2 is x plus 2. And again, awfully tempting to get this 4 and this 2, but again, they are in parentheses. You cannot cancel them. Can't even touch them. The only way you could do that is if the bottom had an x plus 4 or the top had an x plus 2, which it doesn't have. So there you go. So there's this one. Okay. All right, so now we're going to cover division rules. Division rules is really what we've been doing with one added step. And it's going to be at the very beginning here, okay? So our added step is going to say, okay, here, let me shrink this so I can see it, okay? That says, in step 1, we're going to flip the fraction behind the division sign and turn the function to multiply. So flip the guy multiplies in English. Or some of you heard it as KFC, keep, flip, change, okay? So what we're going to do is you're going to flip the fraction behind over and then change the division to multiply, and then we're on our way again. Okay, so let's take a look.
Is it right here?
All right, so here we go. Let's take a look at our first division problem. So again, like we had before, but we have our new step that we have to worry about. So we have to start by, we're going to flip this fraction over and change this to multiply. Yeah, so we're going to have 2a over a plus 3. And again, I'm going to put that in parentheses because I like things with plus or minuses in parentheses. Times, we're going to have a plus 3. Come on, 3.
Come on.
Come on. Oh, I think no, I shut off my pen. Over, we're going to have a plus 7. Okay, so we have, that's all step 1 is. Flip the fraction over. Now our next step, now we're back to doing what we've been doing. So, next step, factor everything. Well, can I factor anything? Well, no, because 2a is a monomial, can't do much with that. A plus 3 is not factorable. A plus 3 not factorable. A plus 7 not factorable. Okay, so I can't factor. So, let's reduce. So, notice how there's no free and single pieces on the outside other than this 2a. So, I can't do any reducing with the monomials. So, now let's do the pieces on the parentheses. So, we've got an a plus 3 with an a plus 3. So, these cancel. And that's all I can do. So, let's factor everything. So, this goes to 1 and 1. Now, let's multiply. So 2a times 1 is 2a over 1 times a plus 7 is a plus 7. So it looks like that. Now, reduce, try to reduce. Now again, awfully tempting to go for these a's, but you can't. This is a monomial, this is in a parenthesis. You can't reduce them. So there it is. It's enough. Alright, so let's look at this next one. Okay. So to begin, now notice how the second piece is not a fraction. So we need to start by making it 1. So let's put this thing over 1. Okay. So let's start our process. So the first step says we got to flip this fraction over because it's directly behind the division. And we're going to change the divide to multiply. So, thank you. So we have 2, thank you for the blanket. Okay, so 2m plus 6 over m plus 5, and again I'm going to put those in parentheses, times 1 over m plus 3. Okay, so now we have that. So now we've done step 1. So step 2 now says to factor everything. Be careful, she's on the edge of that chair. So here I can take out GCF, so kick out the 2, left with m plus 3 over m plus 5 times 1 over m plus 3. Okay, so that's the only factor I could do was that GCF. So step 2 done. Step 3, reduce. Well, again, looking at the monomials, pieces on the outside, all I have is the 2, so I can't do any reducing there. So let's go to stuff inside the parenthesis. We have the m plus 3. Shh. So we have the m plus 3's. I can cancel these. Okay, so this turns to 1 here because there's nothing left. So let's multiply. 2 times 1 is 2. M plus 5 times 1 is m plus 5. Okay. Now our last step, try to reduce if we can, but 2 and m plus 5, that's not happening with anything, so there's your answer there. Alright, so let's take a look at this next one, a division problem. So first thing we do, we got to flip the fraction behind the division sign. So that's this guy. So let's flip this. So we're going to have x over x plus 2. Okay. Times, now when I flip this, the x squared comes down here. And we're going to have the x squared plus 5x plus 6. So it looks like this. Okay. Now my next step, factor. Well, the first fraction, I can't do any factoring. But here, I can factor using PS2. So 2 numbers that multiply 6 but add to 5 are 3 and 2.
What's wrong, Gwen?
What's the matter, Gwen? You want up. All right, hold on, please.
No.
No? Okay. So x squared. All right, now, my next step. Let's start to reduce. Now, notice on the x's, these are free and single pieces. They're not in a parenthesis. So we can play the higher-lower game. So between x and x squared, okay, I'm going to go lower, and then 2 minus 1 is 1. So this cancels. I leave just an x to the first, and this becomes just 1. Now, let's go to other pieces. So x plus 3. Are there any x plus 3's in the bottom? Nope. The x plus 2. I got one right here, so these can cancel. Okay, so I'm left with this. Okay. So now our next step, let's multiply. So 1 with x plus 3. X plus 3 over. Now this turns to 1, so 1 times x is just x. So we have that. Then my last step, try to reduce. Now again, awfully tempting to go for these x's, but you can't because this is in a parenthesis, this is not, so you can't go after those. Okay? So, this right here is our final answer. Alright, now this next one is going to be a mess. Just to warn you, we've got a lot of advanced things going on here. Okay, so let's begin. Start with the easy part. Flip the fraction directly behind the division. X squared minus y squared. X plus y. Times, this is now x minus y. Gwen, divided by x cubed minus y cubed. You can have your binky. And your blanket. There you go, there's your blanket. Okay, so now, here's the fun part. We now need to start factoring. Well, this one should be pretty easy. That's difference of squares. Okay, 2 perfect squares with a minus between. So you're going to have x minus y, x plus y. Okay. The bottom of this is just x plus y. That's easy. The top of this, easy. That's just x minus y. Here's where the fun begins, right here. This is difference of cubic. Okay? So remember, to do difference a cube, the first parenthesis is our cube root of the pieces. So the cube root of x cubed is x. The cube root of y cubed is y. Now, here's where we do our cubic stance. Okay. Now, unfortunately, because of my screen here, I can't exactly show you it. So again, I'll have to just explain it. So again, the first step of the cubic stance says to square the first. Okay, so we're going to take this first piece, x, and square it. So that's x squared. Second part of the dance says we square the last. So negative y squared is positive y squared. Now for the tricky part, it says we multiply and change the sign. So what that means is we're going to multiply x and negative y and get negative xy. So multiply and then change the sign. So negative xy now becomes positive xy, and that goes in the middle. So plus xy. Okay, so that's what's going to go down here. So we're going to have x minus y with x squared plus xy plus y squared. Okay. Now you can try to factor this, although you're going to find in most cases with a cubic it's not going to factor any further. But you should always try it anyway. Alright, now moving on. So we've now factored everything. Now let's start canceling things. So looking around, now let me get rid of that so no one gets confused that that's there. Okay. So now, looking around, we don't have any monomials in this mess. So we're good there. So now at this point, let's start canceling. So let's do x minus y. Any x minus y's on the bottom? I got one right here. So let's cancel that. Goodbye. X plus y. Well, I've got one right here. So these are gone. So this leaves 1 and 1. Now, x minus y. Is there another x minus y on the bottom? Nope. So we're done. We can't reduce anymore. So let's multiply. So 1 with x minus y is going to be x minus y. 1 with x squared plus xy plus y squared is just going to be x squared plus xy, plus y squared. Okay. Now try to reduce one more time. You can't, so this is it right here. Now this question does come up from time to time. It does happen sometimes, not a whole lot, but I want to prep you for it. Let's say you're running through the problem and your end result you have something like this. Whoops, I don't want that, sorry. So let's say we have 2 with 3x plus 1 over, let's say, x with x minus 2 times, let's say, 3 with x minus 1 all over 4. Not 4, let's make it 5 so it doesn't reduce. And let's have this as x plus 1. Okay, so let's say, for instance, we were running this problem. We reduced everything and got it to this. Now the next step says to multiply. Okay, so multiplying garbage like this, okay, we start with the regular numbers and regular numbers on the outside. Do what we normally do. So for instance, 2 times 3 is going to still be 6. But it comes to the parentheses at this point. They say, well, gee, should I put this together and FOIL it, or distribute, double distribute, binomial multiply, whatever you want to call that function? Okay. My answer is for this, no. What you're going to do is you're going to write this as 3x plus 1, x minus 1 on the top. And leave it like that. You don't have to multiply that out. Okay. On the bottom, x times 5, we still do normally, that's going to be 5x. And then put the parentheses next to each other. So you're going to have x minus 2 with 5x plus 1, or correction, x plus 1. And you're just going to leave it like that, because you can't reduce anymore, you can't simplify, okay? So just leave it right like this, it's perfectly fine. Alright, so that's it for now for this video. Hopefully you got a lot out of it. Okay, I know it's been fun listening to all that craziness that goes around me while I'm trying to teach you. So, again, hopefully you enjoyed this. Hopefully you had fun. And again, I will see you next time.
Yeah,
Gwen, can you say bye-bye?
yeah, everybody's.
Can you say bye-bye?
Okay.
Bye-bye.